Hi, my name is Dinorah Martinez Schulte. I am a co-founder of Manufactura and also I'm professor in Universidad Iberoamericana, Ciudad de Mexico, and Universidad La Salle in Mexico City also. Today, I'm going to present my lecture, Building with Awareness. What's the fusion between tradition and innovation, and why we are working in terms of digital fabrication in Mexico. So I study in architecture in Universidad Iberoamericana, and also after this, I study a master in digital fabrication in ETH Zurich. And in the master, I have a lot of opportunities to work with different material, like plastic, local material, recycled material, textiles, etc. So I'm going to talk about a little bit of how the materials works and what's the impact of each material, and then how we are applying this in Mexico. So first of all, we work with PLA. We did the 3D printing with PLA, this exercise called eggshell. For example, one of the best things in plastic, the plastic dries really fast, and then you can get a really good precision. You can get also play with the shapes, with the, all the measurements, and then also we use the plastic as a formwork to cast concrete. So also in 2019, I worked with recycled plastic from the oceans in the Robotic atelier by the Norman Foster Foundation. And in this case, we built like facade elements, and also these elements was directly worked for thermal insulation. And in this case, like the plastic, the recycled plastic also, it was very useful for this kind of disassemble in different directions that you can see in the pictures. And for example, as Norman Foster said, in terms of sustainability, it's not only the sustainability is about the material. It's also like to fabricate objects that it can be easily disassembled and assembled and transported to city. And then in the MIS, we also do the digital bamboo pavilion, and then we work with 3D printing with PTG and fabrics. In this case, this pavilion was made by different systems like bamboo, the joints, and the textiles. And I was in the textiles team, and for example, we did a very big research about what's the kind of fabrics we can work with to 3D print. And at the end, we select like nylon polyester that also we play with the 3D printing levels of the plastic in the textile. For example, we play, when we have structural stresses, we have more levels of printing, and then we have like less levels of printing when we just want to do aesthetic effect. So in the joints, I was not in this team, of course, but it's also part of the project, and in this case, we also fabricate a very easily system that you can assemble and disassemble these bamboo structures, and then we built this pavilion in less than 3 days. This pavilion also, you can see what's the benefits of using digital fabrication and also like computer design together, and how we can create this kind of aesthetics, this kind of patterns. And this pavilion was exhibited in the Museum of Zurich of Architecture, and here you can see all the system working together. So the main goal of this pavilion is just to see what is the real structural performance and also design performance of a really natural material as a bamboo structure. And then we also work with concrete in this exercise called concrete calligraphy. In this case, we did a lot of facades, for architectural buildings. And in this case, concrete is totally different than plastic. Concrete is a liquid material, and then you can also have a non-stop printing. So what you have to do is just to design one single line of the pattern, and also you can have to use less than 2 intersections. So in concrete, what we did, we designed this kind of pattern that they joined in the joints, and then this is the final design. At the end, we select just one of these elements to 3D print one-on-one, and this is the result. Then we also started to connect these facade elements, not just in the interior and the exterior, to create a microclimate in the building system. Then, earth. Well, in this case, we did the second pavilion in the MIS called rapid clay formations. In this case, we use the machine as the constructor. We use also the precision and the labor force of the robot to connect and knit these air bullets. And also one student also fabricated the tool, and it was also using by pressure. At the beginning, this pavilion was planned to be in Brazil, but this pavilion was also fabricated at the same time of the COVID-19. So at the end, we use earth from Switzerland. And with earth, I want to mention something that is totally different. Like when you change your geographical location, you change absolutely everything with earth because you change the components. So in this case, we started to find these kind of failures that also it's an opportunity to study what is the most optimal mix to use the earth. And actually, this project we didn't finish together. And then, while my master's degree, like my partner, Edurne Morales, she continued this to study what is the most optimized mix in the earth construction. And then also, when we are working with robotic fabrication, we have a limited space of working. So in this case, we also have to do like a really strategy to try to merge all the pieces together. And at the end, this is the final result made by Grammaticolor. And then for my master thesis, I did this fly ash waste recycle transformed to mineral foam. And for example, as a designers and architectures, we need to use a more optimized systems to construction as 3D printing and also more friendly materials as mineral foam. So in this case, I put this in the table too, because in Mexico, we also use this kind of lattices to create this microclimate in between the interior and the exterior. So in this case, if you can see the image, it's super interesting because we only are using one element, that is the concrete block, to perform as everything, as the support of the bed, as the wall, as the window, as everything. So with digital fabrication, we can also like transform these kind of elements and also try to perform as different things of necessities. So in this case, I did my master in different stages as design, material, and the fabrication method. In the fabrication method, I 3D print in 10 minutes, then I get dry these pieces in 48 hours, and then I sinterate in an oven. So this is how the 3D print with mineral foam looks like before the firing process, and then this is after the firing process. If you can see, it looks like clay, but it's not a clay. This is a mineral foam, and then you can see also the bubbles in the material. So I use a 3D print, a robotic arm, a material extruder, and a printing bed. And at the end, I did this geometric matrix just to study what is the most optimal geometries to work with this material. I did more than 50 prototyping and different stages of strategies to 3D print. And my first objective was, how can I get the best quality of printing? So I played with my matrix about layer height, layer width, robot speed, foot rate, and the nozzle diameter. So then I found this. So as you can see in the image, the first picture, the first layers are splashing, but then after the layer 3, it started to expand because it's a foam. So I have to design with this condition because this is the material condition. And my second goal is how to get the maximum height. So in this case, I was at the beginning just printing the perimeter, and then I started to have a strategy to get different kind of infills. And at the end, also I realized that I cannot print outside my trajectory. And I compare all of the geometries in terms of weight, volume of material, and time of printing. And if you can see, the circle is the most optimized geometry. So I selected this as my final geometry, and then I started to assemble in different ways. And also I realized something. If I don't flip these objects, I can get a wall application. If I flip it, I can get a screen. And then I started to study both architectural applications. The first one was the wall. But for the wall, I need 200 bricks. And this is how it looks like in an architectural space. And then for a screen, I just need 24 bricks. And this is also more optimized, so this is why I selected as my final prototype. And one of the interesting things about this material is super lightweight because the density is super low. So in this case, the final product is around 50 kilograms. So this is the final image in how I fabricate with this material. I also create this microclimate that we were talking about before, and this is the final result. So at the end, I get the goal about controlling the shadowing and the natural lighting. But I not only do digital projects with digital fabrication, I also work with Ensemble Studio, and I did this project that is called Domo Canvas. Domo Canvas is the furniture for this big pavilion that was in Montana in United States. In this case, I work with my hands, totally by hand. I knit these furnitures by myself alone as an Hermes bag, and then I also fabric. Now I use this kind of fabric made by concrete. So if you add water, then you can play with this kind of fabric, and then you can create very different wrinkles in the fabric. So I really love this image because I did these 3 outputs. So most of the people think I did the geometry first in the computer, and then I 3D printed, and again I did the list. But no, like the real thing, I did the furniture first, and then thank you for 3D scanning and Grasshopper, I can get digital fabrication outputs as CNC milling or 3D printing. So, but I also asked, what happens if we do it in the other way around? So that's why we started our studio called Manufactura. Manufactura is also a studio founded by myself, Edurne Morales, and Eduardo Barba. And right now, what we are doing is this. We are merging the tradition and the innovation. Why? Because we believe in the use of technology for a sustainable future-built environment. Building an innovative future based on tradition and developing dialogues between digital fabrication and humanity. We are located in Dr. Erazo in Colonia Doctores in Mexico City, and we have a robotic arm that which also allows us to work with different materials. So in this case, our material research is very local and traditional materials like local clays, earth, and ceramics, but also, on the other hand, we have a lot of recycled materials. So what is our services? We do additive manufacturing, also subtractive manufacturing, and automated manufacturing. So the first project I'm going to present is the eggshell project that we do in collaboration with Montserrat Ayala. The question is, it is possible to beat with our waste? The answer is yes. So we started to discover what we can do with the eggshell. Why eggshell? Because Mexico is the first producer of egg in the world and also the 4th consumer of eggshell. We always have egg in our diet, really present. So there is a lot of waste of this material in my country. So we also started to play what happened with this waste. So we started first to study the material by hand. To destroy it, we do a PLA cast, and then we just put this material to understand how this material behaves. After this, we digitalize this material to allow in the 3D printing. So we destroy this material in a really small pieces, then we sanitize it, and then we agglomerate with xanthan gum, a lot of organic agglomerants, and at the end, we got this. We got a really nice bioceramic that allows us to 3D print several pieces in our robotic arm. So this is a robotic arm, and with a ceramic extruder in a normal temperature, we are allowed to 3D print, and this is the result. So right now, also, it's very interesting, the 3D printing with eggshell, because if you can see, you can also see the material. You can also see the nature of the eggshell, and if you change the color of the eggshell, you change the color of the final pieces. And also, this is how it looks like before the drying system. And one of the interesting parts of this biocomposite, in comparison with ceramics, you don't need a firing process. With the normal temperature, you can get it dry and get it stressed and get the better structural performance. So also, we do geometrical studies about which one is the most optimal. At the end, we select this one and this structure and this size as the most optimal geometry and measurements to work with this material. So at the end, we do the first prototype made by 115 pieces, and we do a wall totally assembled by hand, but this wall also was designed for to be assembled each other to have a really good structural stability. So this is how the texture looks like now in the outside, and as I mentioned, this is the result of working with our waste. It's totally possible, and it's also super, very close to a normal ceramic. So this is the first prototype we do, and we expose this in Design Week Mexico 2022. And the second prototype we work with the same material is this column. This column was made by also a guest designer, Maria Piazas, and she was designing also a tower made by 3 towers connected by a computational design. Also, we were guessing what happened if we change the brick size, and what happened is also we changed the infill size in a very parametrical way. So this column was constructed by 30 pieces all of them are totally different. So also this is the result of the material, and they assemble each other all over, like one on top of the other one, and then at the end it's totally possible to build with our waste. Right now we are in a stage that we are studying the structural behaviors, and also we also want to bring this material as a construction material to be possible to be using in the construction sector. So I also want to present another projects that we do. We also work with ceramics. In this case, we do these candles in collaboration with Amphora Studio and the New Sanctuaries. In this case, the client was doing like a perfume and an exhibition to get a perfume. So she asked me, can the ceramic have a smell? The answer is no, ceramic cannot have a smell. But we use a plaster that is very common in Mexico called chucum, that it comes from the pre-Hispanic, our ancestor of vernacular material, that is a plaster that we added after the firing process to get the perfume inside these candles. So this is the exhibition that we made, and this is how the candles look like. And also digital fabrication allows us to have this kind of aesthetics, no? And we use the 3D printing with normal local ceramic, and after this, we fire these pieces, and then we add the chucum like in top of this to get the smell. So our third project is Sueños with Earth and Concrete. We work with the MIT Digital Structures, HLA, and the New Story. In this case, we were doing a pavilion that was exhibited last year for Mextropoli Festival of Architecture in Mexico City. And in this case, we combine 3 different materials that is always using in affordable housing in Mexico. What is these materials? Compressed air blocks that made by HLA, the precast concrete that also, this precast concrete is super interesting because it was changing the shape for having a better structural performance. So in this case, what we did is the bovedillas. This system is named in Spanish vigueta and bovedilla, that is super traditional using in Mexico. So in this case, because the precast beam, it was changing the shape, of course the beams was also changing the shape. So we have 18 different pieces, and then we repeat this 10 times. So at the end, we did it with digital fabrication and robotics, and we collaborate with Amphora to work with a really local material that came from 2 regions of Mexico. The one is the Oaxaca clay. Oaxaca clay gives the color and the texture, and the Zacatecas clay, it gives, because it have a lot of sand, a lot of reinforcement and structure behavior. So at the end, this is how the beams look like before the firing process, and this is the final result. At the end, we have these beams that they are working together, and they have the super common terracotta color that everybody loves from Mexico. So at the end, this is the complete beam, and if you can see also, the geometry is started to be flat, and then to get more curvy, to get more structural performance. And at the end, we fabricated more than 200 pieces, and then we collocated in the pavilion by hand with the constructors. Then we build it, and this is the final result. A very nice roof made by a local material, but with digital fabrication and computational design. And this year, we developed the wood project that is also the same mix that we use with the egg, but now with a lot of sawdust. We collaborate with La Metropolitana, who they are a really big designers of furniture, and they are always working with wood. But they told us a very big issue that they have in their fabric. They have a lot of waste of sawdust. They produce more than 50 kilograms per machine per day. That is super unhealthy also for the workers to always smell in these sawdust, and they have idea what to do with this. So in this case, we work with Salam, that is a species located in the southwest of Mexico, super traditional because it was used for the Maya tradition. And then we just also applying with the same mix of the eggshell to see if it works, and it's totally working. Like right now, we are allowed to 3D print this, and we fabricated like different kind of bricks, and also if you can see, this is how it looks like when it dried, and you can see the natural of the sawdust, no? This is the final geometries that we also fabricated, and also also in the same process with the eggshell, we don't use an oven for this. We don't use a firing process. We also use the normal temperature, and also we put it on the sun for 24 hours to remove all fungi and all bacteria. So this is the final result. It was a really small facade using for an exposition, and it's totally also allowed to fabricate it with our waste. So I'm also teaching in Universidad Iberoamericana, and in this case with my students, we also research about what happens if we work with traditional ceramic, but with pigments also, how to get color to the ceramic. So in this case, we use this color that is azul colonial. This is the color from Amphora. We collaborate with them again, and it's the first time that I was trying also to pigment the ceramic, not after the printing, before the printing. So in this case, we study like the area that we were working with, that is our studio, that is a really old factory in Mexico. So my students started to study the side, they started to study all the edges. This is the first iteration they were planning. They were planning to do like a roof system, but at the end, this one was not working for 3D printing. So this is the final shapes. They started also to study and to have different kind of elements. In this case, they have different kinds of pieces, the A, the V, and the C family. And then with computational design, they do a grasshopper pattern, to accommodate this shape. And this one is the final result. They also started to play with the pigments, and I'm gonna start to explain how to add the pigments. So at the beginning, you have the normal clay, and then you add the pigments in different also intensities as deep blue, intermediate, and light material, before doing the firing process, and then you knead them by hand for 20 minutes. And after this, we prepare, this is my students preparing all these bullets of 70 centimeters to get faster printing and also like fooling the material in the tube. And then we got it, a 3D printing blue ceramic made by a traditional clay from Mexico. And then this is how we let it dry for 24 hours. Then we let it dry in an electronic dryer. And then this picture, it's really amazing because this is how the color looks before the firing process, and this is after the firing process. The color gets super stressed, and then they get really hot. And also my students tested this, like if it's a roof system, they have to really work with. So this is the final result. And our last project that we did is this. It's called the Talavera project. Talavera is not ceramic. It's a really prehistorical and also ancestral kind of ceramics. It's from the family of the ceramics, but it came from Spain to Mexico in the like very old, when the Spanish conquered us. So it was also like showing the message from our cultures. And in this case, we want to also like involve innovation in a really protected and traditional method, that is the Talavera. Talavera is protected by the law. You cannot innovate this process. You cannot modify or replace this process because it's part of our cultural heritage. So the people in Urarte Talavera, that is the oldest house of Talavera production, they told us they have two issues. First of all, they cannot be allowed to innovate in any way. And the second, they have a lot of waste. Like, because the material is super protected by the law, they cannot sell it, they cannot use it, like after if one of the pieces get broken or they do not pass the control quality. So what they are mentioning, what we can do with this kind of waste? There is a lot of volume. So we try to, first of all, get from 3D printing ceramics, we get a piece, and then we remove the lines by hand, with a sponge and by hand. We do this because after this, an artisan made the mold in a very traditional plaster. So this is the plaster that they get, and then an artisan, a certificate artisan, because I cannot be part of this, then he molded by hand. And after this, Guadalupe, she's an artist, and then she refined all the pieces by hand. Then they get to glaze it, so this is how it looks like when the material gets glazed. And then another artisan finished it also totally by hand. And then the final step is this, the painting. But the painting is super interesting because it has to be totally by hand, every piece, each piece, and also with a pencil that came from a mule hair, because this is how the law of the culture in the heritage culture is set. So we painted this with a really traditional color that is azul cobalto, or cobalt blue. So at the end, from a very industrial process that it could be the 3D printing and robotics, we also, with digital manufacturing, we do this. We merge and we have a conversation, no, with the traditional fabrication, and this is the final result. This is the piece we fabricated, and we merge the innovation and the tradition in the same space. How we do it? We did this column made by 3D printing pieces, and then they replicated 80 times, and it means the innovation in Talavera process, but then we fill it with a really big carpet of waste, because we want to also question in the people, we can also use our cultural heritage waste. Why we are protecting this? To create more volume or more problems to our environment? So this is the final result, and this is the pieces made totally by an artisan persons. And this one also was exposed in a really famous patio called the Uriarte House in Puebla, Mexico. So this is manufactura. We always have a conversation with the machines. We always have connection with the materials that we work. We always are making new solutions or alternatives through technology to get a more sustainable environment. And we also create community with, for example, these indigenous people that they do not have connection with technology. So at the end, all our tools are made by Mexican manufacturing, and also it's not always like everything is digital. We also do some works after the printing by hand. So also I'm teaching in several universities to trying to explain to my students how to relate it with the material, how to also have a criteria to work with. As a conclusion, I say digital fabrication is not a linear process. It's an infinite loop that is always fit by design fabrication through the material. So what happens when the people are no longer part of the construction? Digital fabrication have a lot of advantages. As you can see, new applications, opportunity to new construction process, use and experimentations of new materials, replicable process, and optimal management. But also have a lot of disadvantages of replacing of the loss of employment, loss of the human touch, changing the labor relationships, as makes visible the inequality between our society. The European book said that in 2057, 2.7 million jobs will be replaced by robots. But Mexico have another condition. More than 60% of the national population are living in extreme poverty. Only 1% of the population represents more than our national GDP. Only 59% have access to internet, and the most important, more than 70% of the population are living in self-built houses. So why labor in Mexico is so cheap? The first thing is because educational lack, and then they have urgency to generate money. Only 4 out of 100 Mexicans have an income more than 50,000 pesos. So Mexico is a totally manufacturing country. Why? Because 6.9 people are engaged in labor force, but in a really risky conditions. So they work for more than 56 hours, and also in the Mexican companies, only the 93% use analog tools, and only the 6% use digital tools. So construction industry in Mexico represents the fourth largest economical sector in Mexico, and it's not being innovated. So robotic construction is not purely craft, it's political, it's cultural, it's economical, and it's social. This is an image about Cemex, presenting the first concrete 3D printing in Mexico. And what's the answer from the people? Los albañiles, disemployment, the workers, they're gonna remove my job. No, this is the answer from the people. So today, energy and raw materials costs are far from irrelevant. Labor costs will be increasingly affected by robotic automation. The question remains, can the revolution still be made by a printing costing more than $25,000? Today, we know these technologies are achievable, but all the social aspects and intellectual works start right now. Automation does not distinguish between design or manufacturing or even economics. They distinguish the obsolescence of the workflow. So my question is, what's the role of the robots in architecture? A robot, this is the European book said, a robot has to be able to work beyond human capability, doing the things that humans could not do effectively, and robots need to be able to make decisions autonomously. I really want to close with this image because this is an artist called Stellark, and he said, there is no more human thing than technology. Why? Because technology has the shape of the human body, and they allow us to get evolution of our species. I did this exercise with my students, and they selected one architectural item. I told them, build someone totally by hand, and then the other one totally automated, and tell me which one is more difficult or complex. So at the end, they told me, working by hand, it was more difficult than working with a robot because they never have a contact with their body, with the material. But that communication with the robot is also a very complex stage. So as Mario Carpo said in his book, Beyond Bending, technology should not replace human contact. There cannot be a community without a physical proximity. So robots have a lot of advantages of optimizing process, precisely, a really good different kind of designs, but also human contact have the most important thing, that is intuition. It's never clear when a human starts and a human ends. Thank you so much.